Continuations of the previous video, there is a difference between spermatogenesis and oogenesis, whereby spermatogenesis only completes the whole process within 74 hours, while oogenesis takes years to complete the whole until producing the oocytes and ovum. So the ooganium already prepared in utero moved from the yolk sac to the ovary and pause at the mysis 1 prephase 1. And then it stopped there until the ovulations occur. The mysis 1 prephase 1 will continue to differentiate into mysis 2 and metaphase 2, and it stopped here during the ovulations. So not all ooganium able to end up with ovum, because it need fertilizations to complete the mysis 2. Okay, so let's talk about what happened after that. So we know that fertilizations may occur 12 hours after the ovulations. So once it's ovulate here, so the fertilizations will happen about 12 hours after ovulation, and it happened in the ampulla region. What happened at that point is that the sperm, it has first of all it needs a capacitations, whereby it needs to wash every single macromolecules from the surface of the sperm, and so that the sperm become more mobile and prepare for the acrosomal reactions. So after acrosomal reactions by the releasings of the hyaluronidase enzyme, the sperm gets dispersed into the zona corona radiata and gets through the zona pellucida, and we have the perivitelline membrane here. So once it gets into here, there will be polyspermic block. So it blocks other sperm to penetrate. So only one sperm able to penetrate one ovum. So what happened after that? At this point, we call this the pronuclei. And then this N plus N will produce a haploid new zygote. And what happened after that? About 30 hours after fertilization, there will be the first cell divisions and becoming 2 cell stage. And it happened at day 2, because 30 hours, right? 24 days, so entering day 2. After that, the cells further mitosis and will become a 4 cell stage. And after that, day 3 now, morula will start to it will divide it and become 8, and then 16. So when the cells become 8, then we call it 8 cell stage or morula, early uncompacted morula. It's look like a blueberry, right? And it goes into the uterine cavity and become a blastoma on day 5. This is the question. So it's day 5 becoming the blastocyst. So the blastocyst will slowly forming a fluid-filled cavity, which will later become the yolk sac. And we have the inner and outer cell. So the blastocyst differentiate itself into the embryoblast and trophoblast. And trophoblast will further divide itself into the syncytiotrophoblasts. Okay, but what I want to highlight is on day 6. So day 5, the implantations started to begin, and on day 6, we have the hatching of the blastocyst from the zona pellucida. It's just like an egg hatching away because it needs to grow, so it needs more space, so it needs to be hatched from the previous cells surrounding it, which is the previous granulosa cells. So hatching occur here, and at the same time the trophoblasts will become syncytiotrophoblasts, and the implantations later will complete day 13. So what happened after that is that the